So this is a type of overlapping, that is a coaxial overlapping, जहाँ atomic orbitals का overlapping तो होगा, so that will take place along common axis. कॉमन एक्सिस पे ओवरलैपिंग जब होगा तो इन दैट केस दैट विल बी कॉल्ड एन कोएक्सियल ओवरलैपिंग. यहाँ पे जो ओवरलैपिंग होता है दैट विल बी टेकिंग प्लेस टू मोर एक्सटेंट, larger extent of overlapping is there, and in that case a strong covalent bond will be formed. But this overlapping is not taking place to 100%. 100% overlapping होगा नहीं orbitals का, because in that case nucleus repulsion will become effective, because these two atomic orbital belongs to or associated with the different nuclei. दो अलग अलग आइटम जब लिए हैं हमने, दो डिफरेंट आइटम्स लिया है आपने, तो उनके न्यूक्लियस भी होंगे, उन्हीं की दो ऑर्बिटल्स है जिसमें अनपेड इलेक्ट्रॉन्स है, एंड दीज अनपेड इलेक्ट्रॉन्स हैव अपोजिट स्पिन. So after overlapping of these atomic orbitals, these unpaired electron gets paired and their spin get neutralized, so that जो इंटरेक्शन होता है इलेक्ट्रॉन इलेक्ट्रॉन का रिपल्शन बोलो चाहे और भी किसी टाइप का इंटरेक्शन है, तो दैट विल बी मिनिमम, एंड इन दैट केस दिस टू एटम रिमेन टुगेदर विथ अ स्ट्रॉन्ग कोवेलेंट बॉन्ड. So how it is formed? It is formed by either SS or SP or PP overlapping, but where it should take place? Along the common axis. Now one of them is SS overlapping. First of all we'll go for this, then this and this one. So okay, shall I wipe this one?
Yes.
Okay. So two S orbitals are required. So what we are doing? SS overlapping. Two S orbitals of two different items. दो अलग अलग आइटम लिए आपने, उनका एस ऑर्बिटल हमको चाहिए, और क्या चाहिए उसमें? कंटेनिंग अनपेयर्ड इलेक्ट्रॉन्स विथ अपोजिट स्पिन. यहाँ पे डायरेक्शन ऑफ स्पिन जो है इलेक्ट्रॉन का वो अपोजिट चाहिए हमको. So two s orbitals of two different atoms containing unpaired electron with opposite spin. When overlaps, coaxial एक word use कर लेते हैं. When they overlaps coaxially means along the common axis. क्या होगा? Unpaired electron get paired, they get paired, and their spin get neutralized, तो यहाँ पे हमने सिर्फ प्योर एटॉमिक ऑर्बिटल्स को ओवरलैप करवाया, अनपेड इलेक्ट्रॉन का पेयरिंग किया, स्पिन न्यूट्रलाइज हो गया, एंड नाउ सच अ पेयर such a pair of electron which is formed during coaxial overlapping is called as shared pair of electron, या फिर very short you can call it as an bond pair or shared pair of electron. So this is the case of HH bond, right? Some more atoms are also there. They are formed by SS overlapping. Such bonds will exist due to SS overlapping. So ये था आपका SS overlapping. हम इसको diagrammatically जब रखना चाहेंगे, डायग्रामेटिकली जब रखेंगे तो यू विल फाइंड दैट एक एस ऑर्बिटल होगा जिसमें एक अनपेड इलेक्ट्रॉन क्लॉकवाइज स्पिन में रहेगा, दूसरा एस ऑर्बिटल होगा जिसमें का अनपेड इलेक्ट्रॉन एंटी क्लॉकवाइज स्पिन में होगा। देन दोनों के कॉम्बिनेशन से आप ओवरलैपिंग बता रहे हैं, तो इन दैट केस जो शेडेड रीजन होगा दैट इज कॉल्ड एज एन ओवरलैप रीजन ऑफ ओवरलैपिंग, एंड इन दैट region of overlapping there exists a shared pair of electron. So now this is what a complete theory about the covalent bond. हम इसके पहले कैसा बोलते थे, the bond which is formed by sharing of electron. Now how that sharing takes place, that may be due to SS overlapping. This is the one case. Now we'll go for another one, that is PP or SP overlapping. So how the diagram should be there. This is your S orbital. It contains one unpaired electron. These are the axes. This is S orbital, or you can say just example के तौर पे आपने लिया one S orbital of hydrogen. One S orbital of one hydrogen atom is there. Then another one is there. This is also S orbital that contains one unpaired electron with opposite spin. यहाँ पे direction of spin opposite होगा. This is one S orbital of another hydrogen. Now after overlapping, what happens? Some part of this will become common, and in this shaded region, this is called as region of overlapping. यहाँ पे क्या होगा? यहाँ पे होगा आपका bond pair या फिर share pair of electron. Share pair भी बोल सकते, shared pair of electron भी बोल सकते, or you can say the bond pair. Now these are the two atomic orbitals that are after overlapping. These are the nuclei, so they will try to remain at a certain distance because इसके बीच का repulsion जो है वो बढ़ना नहीं चाहिए, कम होना चाहिए. So this is the stage where these two atoms remain together. So these are two bonded atoms. How they are remaining. So this is called as SS overlapping. In case of hydrogen, these two nuclei are separated by 0.74 and picometer. This is the case of hydrogen atom. That is the case of hydrogen molecule where two atoms combine together to form a H2 molecule. Hydrogen का जो molecule है, that is a diatomic. That molecule is consisting of two atoms. That consists of two atoms. Molecule consists of two atoms, तो atomicity हो गया 2. तो यहाँ पे how that bond is formed and how much is the distance? 74 picometer. Okay, so shall I wipe all these things?
Yes.
Okay. Now we go for the SP type of overlapping. This is SS. And in case of SP overlapping, that S orbital of one atom, for example, hydrogen is there. This is S orbital of one atom, unpaired electron. Now that will overlap with this orbital called as one is px, so we'll write p orbital only. So suppose this is of hydrogen atom, so you can say this one is 1s orbital of hydrogen atom. 1s orbital of hydrogen atom. Now this is suppose 3p orbital, or you can say that 2p orbital of any that nitrogen भी ले सकते हैं आप. Otherwise you can have that 3p orbital of chlorine, or you can have that 2p orbital of chlorine. They should be of nearly same energy. किसी का भी किसी के साथ overlapping इतने extent में नहीं होता. If they are of nearly same energy, in that case only the overlapping will be to that extent and strong bond will be there. If you take hydrogen and iodine, in that case such overlapping to small extent. This overlapping is just like this one, very small type of overlapping is there. This proportion is less. So in that case, In that case, the nuclei will quite away from each other. Bond length or distance between internuclear distance will be more, and in that case, that bond will be strong. जितना ज्यादा overlapping होगा, उतना strong होगा हमारा bond. And now after overlapping, what happens? See, अब आपके इलेक्ट्रॉन का जो प्रोबेबिलिटी है वो सिर्फ इसी रीजन में मिल रहा है. Probability of this electron will be in this region only. So in that case, second part of this orbital get reduced, or this is called as lobe. What? So second part of this lobe will get reduced. Means either probability जो है electron मिलने का वो near about खत्म हो चुका है, because once they are paired, they will remain in the region of overlapping. Now this is what type of overlapping? That is sp overlapping, and you have this type of molecule, HF molecule. HF, hydrogen fluoride. So s orbital of one atom containing unpaired electron overlaps coaxially with a 2p orbital of another atom. So what is the requirement? These two electrons have opposite spin. So after overlapping, this electron gets paired, their spin get neutralized, and a bond is formed. So how that HF bond is formed? By sp overlapping. If you go for HCl, then also it is sp overlapping. If you go for HI, then that is same. But what is the difference between these three? See here, HF, very short distance. HCl, somewhat longer. Then if you go for HBr, then again somewhat more. And in case of HI, you will find that there is a quite larger distance between these two nuclei of bonded atoms. These are the bonded atoms, and the distance between such bonded atom, internuclear distance होता है वो, and that is called as bond length. ये जितना ज्यादा होगा उतना वो bond weak होगा. Means what? ये जो overlapping हो रहा है ये यहाँ पे सबसे कम होगा. So that's why this bond can be broken down easily. But here that requires a very high amount of energy, because this is a strong bond. Strong bond means overlapping ज्यादा हुआ है. Weak bond means वहां पे atomic orbitals का जो overlapping है वो कम हो गया है, and that's why this bond length is more. Bond length is more, bond energy is less. So that is inverse proportion between bond energy and bond length. You got this one?
Yes.
Okay. Now go to the third one. That is a PP overlapping. यहाँ पे दो अलग type का overlapping हो सकता. Just we are studying the coaxial overlapping. We are studying only coaxial overlapping. So we go for PP. But this is not the case for carbon, then nitrogen, then oxygen, or you can have that particularly beryllium, boron, carbon. इन elements में ये theory काम नहीं करेगी, theory of overlapping or valence bond theory, then boron and carbon. इन एलिमेंट्स के लिए हमारा ये थ्योरी जो है ना ओवरलैपिंग का काम नहीं करता, बिकॉज दिस इज जस्ट सेम एज दैट ऑफ वीबीटी, वैलेंस बॉन्ड थ्योरी, जहां पे बोला जाता है कि जितने अनपेड इलेक्ट्रॉन होंगे ग्राउंड स्टेट में उतने ही बॉन्ड बनने चाहिए. हाउ द बॉन्ड इज फॉर्म बाय ओवरलैपिंग ऑफ atomic orbitals containing unpaired electron with opposite spin. So after overlapping, these unpaired electron gets paired and they remain in the region of overlapping, and in that case strong covalent bond will be formed due to coaxial overlapping, right? But in this case that theory is not applicable. उसके लिए हमको hybridization पे जाना पड़ेगा. Okay, so once we go for the PP overlapping, then we have that F2 molecule. You know, fluorine 9, atomic number of that fluorine is 9. So where that unpaired electron is 1s2, 2s2, you know this one, 2px2, 2py2 and 2pz1. Now this will be the orbital containing unpaired electron, and we have that hydrogen. So how it is? 1s1. Now hydrogen 1s orbital is there. It contains unpaired electron. Now there is a p orbital. Okay, so we are studying PP overlapping. We are not studying the sp. Sp is over now. Okay, so just we go to F2 molecule. So this is your fluorine. अब मैं को Z यहाँ लेना चाहिए horizontal में only, because I don't have any option. बिकॉज ऐसे निकालेंगे तो ओवरलैपिंग कैसे करेंगे. दिस इज सपोज 2pz, सपोज इट इज z एक्सिस, सपोज. So this is what 2pz orbital of one fluorine. Another fluorine is there. That also contains unpaired electron with opposite spin. All right. So now these are the 2p orbitals. Now यहाँ पे जो overlapping होता है वो हमको खास तौर से इस टाइप में चाहिए coaxial overlapping. So this is another p orbital. What happens to the second part? That get reduced. So why it get reduced? Because probability of finding the electron in the second part of this p orbital or second lobe of the orbital becomes 0. So in that case, these two electrons remain there, and here this is called as a what type of electron pair? Shared pair of electron or shared pair of electron or bond pair. This is bond pair. So these are the simple molecules which are formed by overlapping of atomic orbitals. So this is the base of that VBT, valence bond theory. क्या बताता है? That bond is formed by overlapping of atomic orbitals. How the bond is formed? Bond is formed by overlapping of atomic orbitals of different atom. One thing. Second thing, हमारा condition है the overlapping atomic orbitals must contains unpaired electron. Second condition. Then you go to the third one. Such overlapping atomic orbitals must have unpaired electron with opposite spin. Their spin should be opposite. And then such atomic orbitals can overlap by two ways. One of them is coaxial. If there is a coaxial overlapping, then that will give rise to the formation of strong covalent bond because the extent of overlapping is more. So coaxial overlapping giving rise to the larger extent of overlapping, and in that case such a bond will be the stronger one, right? Then same atomic orbitals may overlap sideways. So that partial overlapping will take place, extent will be less, and in that case such a bond will be weaker. ठीक है, यहाँ से आगे चलते. Once the atomic orbital overlaps coaxially, हम coaxial का overlapping करेंगे because we have to explain single covalent bond only. So that will be formed by coaxial overlapping. So after overlapping, these unpaired electron gets paired, their spin get neutralized, and a strong covalent bond is formed. So जितना ज्यादा overlapping होगा उतना वो bond strong होता है. Means what? Larger is the extent of overlapping, stronger is the bond. This doesn't mean that atomic orbitals will overlap to 100%. Extent जो है that will not be 100% because in that case nucleus will be quite closer to each other, and in that case repulsions will increase and stable molecule will not be formed. That's why 100% overlapping of atomic orbital is not possible. Okay.
Yes.
Then one more thing is that number of unpaired electron is in the outermost shell is equal to valency. That is the base of this theory, and that becomes the failure of that theory finally. So we can't explain the valencies of few elements like beryllium having configuration 1s2, 2s2, right? Then we have that boron with atomic number 5, 1s2, 2s2, and 2px1. And then we have the carbon 1s2, 2s2, 2px1, and 2py1. So according to VBT, valence bond theory के हिसाब से the number of unpaired electrons in the valence shell is equal to the valency. So this element should be zero valent, this should be monovalent, and this should be divalent. But these elements can form compounds like BF2 and BeCl2. So where the valency is 2. So valency of beryllium cannot be explained by VBT. If you go for the boron, then this boron can form a compound like BF3. How many bonds? 3 bonds. So valency should be 3. So trivalent nature cannot be explained by this theory. If you go to the carbon, then you will find that, yeah, here 2 electrons in case of carbon. So carbon can form a compound like where valence is 4. So share of beryllium, bivalent nature of this element cannot be explained by VBT. Trivalent nature of this boron cannot be explained by VBT, and tetravalent nature of carbon cannot be explained by VBT. And that's why there was a need of concept of hybridization. So hybridization that will take place in these elements first of all. If you go to that so first of all we study that hybridization concept थोड़ा सा समझ लेते हैं. So hybridization, what we have प्योर एटॉमिक ऑर्बिटल्स. अब यहाँ पे हमको कोई रेस्ट्रिक्शन नहीं कि उसमें अनपेड इलेक्ट्रॉन होना ही चाहिए, बिल्कुल नहीं. हाइब्रिड ऑर्बिटल्स जिसमें अनपेड इलेक्ट्रॉन भी हो सकता, पेयर्ड इलेक्ट्रॉन भी हो सकते. बॉन्ड फॉर्मेशन में ओनली दोज हाइब्रिड ऑर्बिटल विल टेक पार्ट कंटेनिंग अनपेड इलेक्ट्रॉन. यहाँ पे ओवरलैपिंग का जो कंसेप्ट है वो अनपेड इलेक्ट्रॉन विद अपोजिट स्पिन रहेगा ही रहेगा, चाहे थ्योरी कोई भी हो. जब तक का स्पिन न्यूट्रलाइज नहीं होगा, इंटरेक्शन मिनिमम नहीं होगा, रिपल्शन मिनिमम नहीं होगा, तो बॉन्ड कैसे बनेगा. ओके, सो दिस इज व्हाट मिक्सिंग एंड रिकास्टिंग of atomic orbitals. और एक कंडीशन है, सेम एटम की एटॉमिक ऑर्बिटल्स दोज हैविंग नियरली सेम एनर्जी. इन्हीं एटॉमिक ऑर्बिटल्स का ओवरलैपिंग मिक्सिंग एंड रिकास्टिंग करेंगे. मिक्सिंग एंड रिकास्टिंग ऑफ प्योर एटॉमिक ऑर्बिटल्स ऑफ नियरली सेम एनर्जी एटम टू प्रोड्यूस new orbitals. Such new orbitals so formed are called as hybrid orbitals. Hybrid orbitals will be formed by mixing and recasting of atomic orbitals of nearly same energy and of same atom. एक ही एटम के एटॉमिक ऑर्बिटल्स पकड़ेंगे आप. लास्ट शेल में जो भी एटॉमिक ऑर्बिटल्स है हमारे पास में, उन्हीं का हम मिक्सिंग एंड रिकास्टिंग करेंगे, दोज हैविंग सेम एनर्जी टू प्रोड्यूस न्यू ऑर्बिटल्स, एंड सच न्यू ऑर्बिटल्स आर called as hybrid orbitals. These are somewhat more extensive in shape as compared to atomic orbitals. So bond formed by such orbitals will be somewhat more stronger. ठीक है. So अब कितनी बनेगी, जितने नंबर ऑफ ऑर्बिटल्स का आप मिक्सिंग एंड रिकास्टिंग करोगे. फॉर एग्जांपल आई हैव दैट S plus P, then I get 2sp hybrid orbitals. So equivalent number of hybrid orbitals will be formed. During hybridization, if you mix and recast these two orbitals, then you will get only two hybrid orbitals. If you go for S and P, then that will give rise to formation of how many? 3. And they are called as sp2. These are called as sp. And if you go for S plus P plus P plus P, then how many? 1 plus 1 plus 1 plus 1, that will be 4 atomic orbitals का mixing कर रहे, तो you will get 4. So that is called as equivalent number of hybrid orbitals are formed. So these are called as sp3. This name suggests 1s and 3p orbitals are used for hybridization. Some more are also there. If you use the d orbitals for hybridization, then sp3, d, d2, and all that is possible. But presently for organic, you need these things. Okay. Now once these hybrid orbitals are formed, these hybrid orbitals are extensive in shape, means they have somewhat larger shapes. So the overlapping will be more, and in that case, strong covalent bond will be formed. This is the case. Second thing, once these have formed, they orient themselves. अपने आप को arrange कर लेंगी. They orient themselves in a space आजू बाजू में जो जगह अवेलेबल है उधर वो इस तरह से अरेंज करेंगे, देयर शुड बी अ मिनिमम रिपल्शन. Repulsion among these hybrid orbitals should be minimum, and that's why they remain away from each other. So what is that called as an orientation of hybrid orbitals? Now these are the two hybrid orbitals. So how they should remain in the space? They arrange themselves in such a way that there should be minimum repulsion between them. They are having a specific direction. So one sp hybrid orbital will be on this side, then this will be another one. This is the case of carbon in acetylene, where the carbon atoms are sp hybridized. Now these two hybrid orbitals are at an angle of 180 degrees. So they are directed in the space, and that will give rise to definite geometry to the molecule. Here the molecule form will be somewhat linear. So this sp is called as an linear hybridization. sp hybridization is a linear. What is that? What that mean? That 1s orbital of 1s and 1p orbital, 1s and 1p orbital of same atom undergo mixing and recasting to produce two hybrid orbitals. And now these two hybrid orbitals arranged diagonally opposite to each other to minimize the repulsion. To minimize the repulsion, they remain diagonally opposite to each other, and that give rise to the linear geometry to that molecule. अब तक का सिर्फ बॉन्ड कैसे बनता है ये देखा था, लेकिन हाइब्रिडाइजेशन में हाइब्रिड ऑर्बिटल्स अरेंज करेंगे अपने आप को डायरेक्टेड इन द स्पेस विथ मिनिमम रिपल्शन एंड मैक्सिमम सिमेट्री. Minimum repulsion and maximum symmetry of the hybrid orbitals give rise to definite shape or geometry to the molecule. जो चीज VBT में नहीं था वो यहाँ पे आ गया. What is that? Orientation of these hybrid orbitals along the particular axis give rise to minimum repulsion, maximum symmetry, and definite geometry to the molecule. That's why we have that molecule like this is a linear molecule, or you can go for that ethene, double bonded carbon जो होता है, that is formed by sp2 hybridization. And in that case these three hybrid orbitals, अभी तो दो का तो हो गया आपका. If you go for the sp2 hybrid orbitals, then they will lie along these axes. These are the axes of equilateral triangle. So the geometry will be triangular geometry. This is sp2 hybrid orbital, this one is sp2. So in that case the molecule will have the triangular geometry. Now they will arrange like this, and in that case the bond angle is 120. In pure cases this is 120, like this, 120, 120 and 120. So geometry of this molecule will be triangular geometry. So that is why it is called as a triangular hybridization, or you can say sp2 hybridization is a triangular hybridization. Still there are some factors that will disturb the geometry called as a distorted geometry. वो अभी नहीं करेंगे हम. You go for this one. 1s and 3p orbitals undergo mixing and recasting. तो कितने बनने चाहिए? 4. Now ये 4 को किस तरह से अरेंज करना है? 3 तो ऐसे दिखेंगे आपको, चौथा बाहर आ रहा है बोर्ड से तो ऐसे दिखेगा, बोर्ड के पीछे है तो छोटा दिखेगा. And such type of geometry will give rise to tetrahedral geometry. So how these orbitals are arranging? This one is first sp3, second sp3, third sp3, and fourth one. So if you take these points as the corners, then this will be regular tetrahedron, and this is called as tetrahedral hybridization, or you can say sp3. Now इन तीनों की हमको जरूरत कहाँ पड़ती है ऑर्गेनिक में? दिस इज फॉर कार्बन कार्बन ट्रिपल बॉन्ड के लिए हमको जरूरत पड़ेगी, यहाँ पे डबल बॉन्ड के लिए, और यहाँ पे सिंगल बॉन्डेड पड़ेगी. So hope you got all these things.
Yes.